Hey everyone, welcome back. Till now we have covered most of the important STL containers as well as we covered time and space complexity. Today we are going to solve some quizzes based on containers and time and space complexity so you can get a better hang of it. Okay, so let's start with our first question. Average time complexity of pushback. So in a vector pushback, take a wig of 1 which is armatized, right? So armatized is our average time complexity across all the test cases. So our answer will be here wig of 1. Time complexity of random access in vector. Random access means if we have a vector here and we have a value like this, if you want to access value 5 or 8, so that means we are accessing the value randomly, so we can use v and the index number. So accessing the random value in a vector will take wig of 1 time complexity. Worst case time complexity of insert at the beginning in the vector. So this is our vector and we have to insert at the beginning of vector. So we will be inserting at the beginning. So what will happen, the elements in the vector will got shifted to the right and the index values of all the elements will change. So in the worst case our time complexity will become big of n. If we were inserting value at the end, then our time complexity will be big of 1, right? Because in this case we don't have to shift our vectors value. Space complexity of vector storing n elements means we have a vector which is of size n, so it is asking space complexity. If we are storing n elements, so that means it will take n size of vector. Okay, so this is a syntax to declare a vector with the size itself. So in this case we have to use parenthesis, not a square bracket like arrays. The time complexity of push front in a DQ. So we have a DQ, we can push back, we can pop back, we can push front and we can pop front. So the time complexity is big of 1 for all these operations. So our answer will be A. Random access time complexity in DQ. So we can also randomly access value in a DQ, and to access value randomly it will take time complexity of big of 1. Okay, time complexity of push in a stack. We have stack and we are pushing value from the top and the top value will be at the top itself, so the time complexity will take big of 1. Similarly, time complexity of pop in a stack. So we have a value we are removing from the top, so it is performing only one operation, so time complexity will be big of 1. Time complexity of push in a queue. So this is our queue, we can push from the back and pop from the front, so adding a value at the end will take big of 1 time complexity. Time complexity of pop in a queue, so we are removing from here, so it will also take big of 1. Underlying structure of priority queue. Priority queue is implemented using vector itself, means we see a like this, or we inserting a value, it has a max heap and min heap. Max heap always keep largest value at the top, min heap always keep smallest value at the top, and the priority queue using vector to store data. Time complexity of push in priority queue. So we have a priority queue, we first inserted a 5, then we inserted a 2, then the internal arrangement will happen and the 5 will top at the top. So there is internal arrangements which will take time complexity of log n. Time complexity of pop in priority queue, so similar, it will also take a big of n to remove a element. Time complexity of insertion at any position in a list. So we have a list is implemented on linked list, so if we want to insert at any position it will take big of 1, but traversal will take big of n time complexity in worst case, means we have to move from here to here also, right, to insert a node. So insertion will take big of 1 and traversal will take big of n, but here we are talking about insertion. Random access in list has complexity big of n, because you cannot use index based method in a list, so you first have to traverse to that position to access that element, so it will take big of n. Forward list supports which iterator? Forward, right, because forward list can only move forward, it cannot go backward. It is implemented in singly linked list. Space overhead of forward list compared to list. Here space means memory. So the forward list takes less memory than list, right? Because forward list only storing data and next pointer, but list storing data, next pointer and previous pointer. So it is storing extra pointer. That's why it takes more memory compared to the forward list. So in this case our answer will be less. Time complexity of insert in set. So set is storing data in a sorted and unique, right? So if you insert 5 3 2, so it will got sorted internally. So there is some operation, so our time complexity will become log n. Does set allow duplicates? No, set allows only unique. For duplicates we can use multi-set. Multi-set allows duplicate. Yes. Time complexity of find in multi-set. To find a value in a multi-set, it takes big of log n, because it is searching inside the set, so it is taking log n time complexity. Average insert complexity in unordered set. So unordered set, we have our value in a unspecified order, so the insert time complexity in average case takes only big of 1, right? Because there is no internal arrangements happening, so it is like inserting a value at the end. So in average case it takes big of 1. Worst case find in unordered set means what will be the time complexity in unordered set if we are using find function. It will take big of n, because there is a concept of hash collision. You can read it on a Google. So once in a million there is a case where this can happen. Okay, in that case time complexity will become big of n. Time complexity of insert in a map. So map also store sorted and unique, right? So it will take log n. Map maintains order. Yes, it is sorted. So yes. Multi-map allows duplicate keys. Yes, right? In a map we can use unique, but in the multi-map we can store duplicate keys. Average search in unordered map means if we are searching an element in an unordered map, then the average time complexity will be big of 1. Worst case unordered map search. So in worst case it is unordered, so it will take big of, because it might have to search whole map to find the value. Pair stores how many value? So it is a pair, it is 2, right? Access time of pair dot first, right? So let's say if we have a pair of int p and the value is like this, right? If you want to access this value, which is p dot first, so the time complexity will be bigger 1, because we are accessing first value. Container with best cache locality means cache is kind of memory which stores frequent data. So question is container with best cache locality means which container stores frequently accessed data locally in our system. So vector is our answer, because vector is only container from this list which stores data in a contiguous memory, right? So if you have a vector like this, if you have a pointer here, you can easily access this value because they are continuous in memory. But in the case of list, set, map, they are not continuous. Okay, so that's why it is best cache locality. Cache means frequent memory, locality means in a local system. Okay, FIFO structure. FIFO means first in, first out. So which container allows us this operation? So means the value which first got inserted will be first out. So this value we first inserted, then 2 3 4 5, then we want to remove this value, we have to perform front operation. So in this case Q is the one which can use first in first out operations. LIFO means last in first out. So to perform this operation we have a stack, right? Last in first out, so our answer will be stack. Sorted container, unordered set, no. Vector, no. DQ, no. So our answer is set. Container for frequency count. So let's see what is frequency count. Let's say if you have a vector vector of value like this. Okay, so frequency count means how many times a element is exist in a vector. Let's say 1. How many times 1 is available in this vector? 1, 2 times, right? Similarly, let's take a 2. How many times 2 is present in the vector? It is 2 times. Let's take another. How many times 3 is present in the vector? It is 2. Then 5. How many times it is present? 1 time, right? So these are our frequency count. So for frequency count, we can store in a map as well as in a unordered map, right? Because it is a key, it is a value, so we can store map and in a map as well as in a unordered map. But now we have to choose which container will take less time complexity. So map will take and login, right? Because it will searching and then inserting. Unordered map will take big of 1 in average cases, and in the worst case it will take big of n. Random access iterator supported by random access means we can randomly access our element in a arrays of data, so only vector allows in the time complexity of big of 1. Container with least memory overhead means which containers taking less memory, which is vector, because list storing in the form of node and node is of data and pointer. Set also storing randomly, not a continuous. Map also storing in a key value. Time complexity of traversing map, so we are traversing a map and using our range based loop. So in our worst case, so our time complexity will become big of n because we are traversing our whole map. Forward list insertion after position, so after certain position we are inserting a value, right? So it will take big of 1 because insertion takes 1 but traversal take, and dq pushback time complexity it is 1. Priority queue top time complexity is 1. Space complexity of set with n elements, it is n because we are storing n elements. Container using hashing, it is unordered map. Okay, hashing is a technique used to store and retrieve data efficiently by transforming a given key into a specific index in an array. Means if you have a key value like 1 3 or 2 5, so and this is our vector 0 1 2 3 4 and 5, so the key of the map can be used as a index for the vector itself. So we are using key of a map as a index for a vector to efficiently retrieve data and perform our operation. Also this is also called hash table. Okay, we will look what is hashing techniques. For now you can say we are using keys as a index for a vector. Multi-map traversal complexity, traversal, so it is big of n. Erase in a list given iterator means you have to erase in a list and iterator already given, so the time complexity will be big of 1. Erase in vector in middle, so you have to erase in a middle, so what will happen, the values from the right will got shifted here, so in the worst case it will take big of n, right? Find in vector worst case n because it have to search all the values in the vector. Also the technique called linear search, that is a technique through which we are searching all the elements in the vector. Unordered set maintains order, no. Map find average time complexity means what is the average time complexity when you are using find function. In map it takes log n. Forward list memory compared to the list, it take less memory compared to the list itself. Okay, that's it for the quizzes. I hope you are able to recall all of the containers and as well as the time complexities of the operations performing on these containers. And as we will keep solving problems, we will also keep analyzing the time and space complexity, so you will be able to understand more of it. Thank you everyone, have a nice day.